Good morning, students. In today's class, we will see some examples of JJ coupling. Consider first we will see the case of a PD configuration. So one electron is in the P shell and the second electron is in the D shell. So here S1 is equal to half, L1 is equal to 1 for P electron, S2 equal to half and L2 equal to 2. This is for the D electron. Now as per JJ coupling, we have S1 and L1 should combine to give a J1 and S2 and L2 combine to give a J2. Then this J1 and J2 couple to give the resultant J value. So here J1 is equal to corresponding to S1 is equal to half, L1 is equal to 1. So you will be having two values possible, 3 by 2 and 1 by 2. And similarly for J2, 2 plus half will give you 5 by 2, 2 minus half will give you 3 by 2. So you have 4 values are possible, 1 by 2, 3 by 2, 5 by 2 and 3 by 2. Now we will vectorially add all these two so that we will get the resultant J value. Now J1 is equal to half, J2 equal to 3 by 2. So if you add this, J will be having two values, that is 3 plus 1, 4 by 2, that will give you 2, and 3 minus 1 by 2, that will give you 1. So the capital J will have two values, 2, 1. Now J1 is equal to 3 by 2, J2 equal to 3 by 2, so that 3 plus 3 is 6 by 2. So the values are 3, 2, 1, 0. That means J1 plus J2 to J1 minus J2 values are possible. So J1 plus J2 will give you 3, J1 plus J2 minus 1 will give you 2, and J1 plus J2 minus 2 will give you 1, and the last one is J1 minus J2, that will give you 0. So the values are 3, 2, 1, 0. Now J1 equal to half, J2 equal to 5 by 2. So 6 by 2, 3. And J1 minus J2 is 2. So only two values, 3 and 2. And J1 is equal to 3 by 2, J2 equal to 5 by 2. So 5 plus 3, 8 by 2, 4. 5 minus 3 is 2 by 2, that is 1. And you have J1 plus J2 minus 1, J1 plus J2 minus 2. So that will give you 4, 3, 2, 1. So these are the possible values of J. So you can see that the J values are same as that obtained from LS coupling scheme. So you can have a look at the previous class where we have done the LS coupling scheme for a PD electron. We got the same J values here and in the previous case also. Now the question is how to represent the states in JJ coupling. So JJ's coupling scheme, the states are denoted by the notation J1, J2, J. That means J1 equal to half, J2 equal to 3 by 2. The J values are 2, 1. So the states can be represented as half, 3 by 2, 2. Then again half, 3 by 2, 1. So earlier we had a general notation 2s plus 1. Then at the corresponding L value and then J. Instead of that, here we are following this type of representation in JJ coupling. Ultimately the J values are going to be the same in both the cases. So we have seen that for an electron, because of LS coupling or JJ coupling, there will be a number of states are available. Now the question is that if you have these many states, then what is the ground state, or how you can represent the minimum energy state of the electrons. So this can be done with the help of Hund's rule. So there are mainly three important rules in this. So we will see one by one. So Hund's rule, when angular momentum of number of electrons are combined, we get number of possible values of L, S and J. Of these, which one has the lowest energy and the order in which the energy increases are governed by Hund's rule. So the first rule says that the total spin angular momentum S should be maximized consistent with Pauli's exclusion principle. As per the Pauli's exclusion principle, no two electron can have all the quantum numbers identical. So as per the Hund's rule, first you have to find out the value of S such that ms will give you its maximum value. So you have to add up in such a way that ms gives the ms maximum should be the corresponding S value. Now for that S, L should be maximized consistent with the Pauli's exclusion principle. Then L equal to ml maximum. Then suppose if the outer shell, so we have S, we have L. Now if the outer shell of an atom is less than half full, the term having the lowest J value will have the minimum energy. Suppose you have a D shell, outer shell is D shell, which is having only 3 electrons. That means it is a half filled shell. It is less than half filled. That means for D shell, the maximum number of electrons is 10. So if it is only having 3 electrons, that means it is less than half filled. In that case, the J value is the 1. You have to take the J value which is minimum. Whereas if the D shell is having more than 5 electrons, in that case you can call the shell as more than half filled shell. So the term with the maximum J value will be having the lowest energy. So you have to be very careful about this. So this type of questions will be asked in competitive exams. Find the ground state of the corresponding atom or molecule. So that time you can use this rule to find out the ground state. So in order to have a better understanding of this rule, we will try to do some problems. So the first question is, obtain the ground state of oxygen. So you know that oxygen is having a atomic number of 8. So the subshell configuration is 1s2, 2s2, 2p4. So there are 4 electrons in the valence shell. This is the valence shell because this is the outermost shell. So it is more than half filled, because for P the maximum number of electrons is 6. Since it is having 4 electrons, it is more than half filled. Now we have to find out, first we have to find out the S value. So for each electron, 4 electrons are there. So ms can have 2 values, either plus half or minus half. So for all the 4 electrons, they can have plus half, minus half, plus half, minus half, plus half, minus half, plus half, minus half. So what we have to do is we have to maximize the ms. So we will assume that first electron will be having an ms value of half, second is having half, third one is having half, and the fourth one will be having a value of minus half. So if you are taking minus half for all the electrons, then it will not represent the maximum value. So instead of that, we will take the plus values and we will try to have a maximum value of ms. So this, when you add this together, half plus half plus half minus half, this will give you a value of 1. That means in this case S is equal to 1. Now we have to maximize ml consistent with the value of S value. So to maximize ml, assign the maximum value of ml equal to 1 for the first electron. Here also you have 4 electrons, L equal to 1. That means 12 plus 1 values are possible for ml, ranging from minus L to plus L. But we have to maximize the value of L, so that we will take ml equal to 1 for the first electron, ml equal to 0 for the second, ml equal to minus 1 for the third, ml equal to 1 for the fourth. Here you cannot take ml equal to 1 for all the electrons, because no 2 electrons can have all the quantum numbers identical. Already ms is equal to half for all the 3 electrons. So you have to take different values of ml. Now if you add together, this will give you a resultant value of 1. So ml maximum is nothing but your capital L. So now we have for the ground state L equal to 1, S equal to 1. So now L equal to 1, S equal to 1 will give you 1 plus 1 2, then 1 minus 1 0, then 2 1 0 will be the values of G. So the ground state the term is 3p210. The term symbol for the electrons is 3p210. So out of these the lowest state is 3p2 because the atom the subshell is more than half filled. The ground state is 1 which is having the maximum J value. Here the maximum J value is 2. Therefore the ground state is nothing but 3p2. Now I'll do one more example. Same situation for nitrogen. For nitrogen, find the value of L and S for the ground state and write the ground state term. Nitrogen Z is equal to 7, 1s2, 2s2, 2p3. Now we have 3 electrons, so ms maximum. Now if you put half plus half plus half, then 3 by 2 will be the S value. Ml maximum, L equal to 1 0 minus 1. These are the 3 values of ml, so that will lead to a 0 value. Therefore J will be equal to 3 by 2. So multiplicity is nothing but 2 into 3 by 2 plus 1, that's equal to 4. Then L equal to 0, that corresponds to an S state. Therefore 4s 3 by 2 is the ground state of nitrogen. So now as a homework, you try to find out the ground state term corresponding to phosphorus, which is having a configuration of 1s2, 2s2, 2p6, 3s2, 3p2. So if you have any doubts, you can always ask me. Thank you for listening.